And welcome again to College Algebra. This time we'll be talking about P6, where we will be factoring. Now, factoring is an operation we've done with numbers before, with real numbers. Factoring literally means to just rewrite as a multiplication. We've done this with numbers like 24, where we've broken them down into multiplications. For example, 6 times 4 would be a factorization of 24. And you could even break it down further to prime factors would be 2 times 2 times 2 times 3. Yeah, 8 times 3. And you couldn't break it down any further than that, really. We're going to be doing the same kind of thing with polynomials. We're going to be rewriting polynomials as multiplications. But we're going to be spending most of our time in this section and in this section's videos doing examples where we talk about these different factoring methods. We're going to be looking at 4 different methods, or at least 4 different classes of methods. And the first one we're going to start with is really the simplest, but also the most versatile. We're going to look at common factors, or the GCF. In these problems, we're going to factor these by pulling out common factors. Now, after a certain point in this set of exercise, I'm just going to stop saying what the instruction is, because the instruction for basically every problem in this section is factor. It might have some extra language after it, but the instruction is basically factor. So, I'm going to start off with this exercise 7. All we're going to do is pull out common factors. So if you'll notice here, there's an x in both terms. So I will pull that out. This equals x times negative 2x squared plus 16. Now note, this is, as we've said before, the exact opposite of what we were doing at the end of P5. In P5, we were taking this x and distributing it through. Now, we're doing the opposite. We're pulling it out. Notice I have to divide it out of each term. Now, that's not all I can pull out. There's also a 2. And I can pull out a 2 or a negative 2. It doesn't really matter. I think I will pull out a negative 2. So now I have negative 2x on the front. And divide negative 2 from the x squared, negative 2x squared, and you'll get just x squared. Divide negative 2 out of the 16, you'll get minus 8. And we've pulled out the common factor. The reason this method is also sometimes called the GCF is because the factor out front here, when you finish pulling out common factors, is the greatest common factor you could have pulled out. And that's what GCF stands for. Greatest common factor. Down here I think I will leave the negatives in place and just pull out a, let's see, what's common? We have a 7. We have at least one x in everything. And we have at least 2 y's in everything. So that will be my GCF. If I divide that out of each term, still have the negative, I will have 3 x's left in this first term. I won't have any y's, so that's done there. Plus, I should have 2. Took away an x, took away 2 y's, so I should still have 1 y left. Plus, divided by 7, so that will be 3. Took away an x, took away 2 y's, so I should have y squared. And this one, we divided by the entire term, so don't think this should be 0, because remember, we divided by it. So if you divide something by itself, it is still going to be 1. And we're good. That is the answer right there. Moving along. Exercise 11. By the way, this exercise here, I think it was originally 10, but I added another term to change it slightly. So it's very similar to a problem in the book, but it has an extra term, so it is something I created an extra term for, but I think it's close to exercise 10 in the book. And on exercise 11, this is a little different, but it's still the same concept. You have this y minus 6 parentheses that is common. You can just treat it like as if it were yx plus 9x. In that case, you would pull out the x. In this case, we're going to pull out the parentheses. If I do that, divide it out of both terms, I will have a y left in the first term, and I will have a 9 left in the second term. This will actually lead us into factoring by grouping later. When we're factoring by grouping in certain types of expressions, we'll get this kind of thing popping up a lot. 12 is along the same lines as 11. It has a slightly different form, but you can still see you have a parentheses common, the z plus 2. So if I pull out a z plus 2, if I divide z plus 2 squared by z plus 2, it's just like if I divided x squared by x. I'd subtract the exponents and get x. Same thing here, z plus 2. So in that first term, I will have a z plus 2 left. And then if I divide z plus 2 out of this one, there's only 1, so it's just going to divide away, and I'll have z plus 2 minus 5. And then I can combine like terms in that right parentheses. So I will have z minus 3. Exercise 57 here is a little bit more tricky. That's why I took the initiative in actually writing out the entire instruction, because this hint is kind of important the first time you see one of these problems. We are still going to be pulling out common factors, but this problem tells us you should really look at factoring out the lowest power of each common factor when you have positives and negatives to consider. And these fractions as well. So you can see we have x's common, and we have x minus 2's common. The lowest power that x had was 1/3, so I'm going to pull out x to the 1/3. The lowest power that x minus 2 had was... Well, actually, let's just do x to the 1/3 first. I'll do the x minus 2's next. So if I divide by x to the 1/3, I'll still have that 2 out front. The x to the 1/3 will be gone in this term, because divide anything by itself, it just goes to 1. And I'll still have that x minus 2 to the 2/3 minus 5. If I take x to the 4/3 and divide out x to the 1/3, that will leave me with x to the 3/3. Let's subtract the exponents, which will just be x. So this should be 5x. And then I haven't done anything with the x minus 2's yet. I'm actually going to use square brackets here instead of... Since I have two levels of parentheses, it's easier to see where one starts and the other begins if you use square brackets for one of the set of parentheses and parentheses for the other. Now I'm going to pull out the x minus 2. The smallest power I had on x minus 2 is negative 1/3 right there. There we go. So let's see what we're going to have left after we do that. We will still have the 2. And if you look at x minus 2 to the 2/3 and divide by x minus 2 to the negative 1/3, if I subtract negative 1/3 from 2/3, that'll be the same thing as adding 1/3. So again, we will end up with three-thirds, and that will be just x minus 2 to the 1. So this is going to be x minus 2. Then I'll still have the minus 5x. And I divided out x minus 2 to the negative 1/3, so that factor will just go away completely. Alright. Now we just have to do some cleanup at the end. This parentheses can be simplified because I've got some like terms after I remove that parentheses inside. So 2x minus 4 minus 5x. I can combine the 2x and the 5. Negative 3x minus 4. X to the 1/2. X minus 2 to the negative 1/3. On the next step, I think I'll use regular parentheses instead of square brackets, since I don't have two levels of parentheses anymore. Last step here, what I want to do is just take my factor with a negative exponent and put it on the bottom. So my final answer should be x to the 1/2 times negative 3x minus 4 over x minus 2 to the 1/3. And that's our final answer. Whoop. So even though these problems might look a little bit daunting, it's still just factoring out common factors. You've just got to be willing to engage with the fractions. I know some people are still pretty shy of fractions after intermediate algebra, but it's a necessary skill, so it's good to practice. I think we'll end the first video here, now that we've finished talking about the first factoring method, the pulling out common factors. We'll deal with probably the next two in the next video. I'll talk to you then.